Welcome to Ask Guidance. My name is Rahul Bisla, and today we'll be discussing the chapter Relations and Functions of Grade 11. Right. But before we start the discussion of this chapter, I just want to confirm from you guys whether you have a clear understanding of chapter sets or not. Because that is something that will be highly utilizing in this chapter. Right. So, without wasting any further time, we'll be starting the chapter of 11th grade, which is Relations and Functions. Right. These two words we have heard a lot, many number of times in our day-to-day life also. Relations, yes, we do have some relations like family relations. We might be having your parents, grandparents, siblings, cousins, maternal uncles and aunts, paternal uncles and aunts, and all those things. And with functions, a colloquial term which we use for some kind of arrangement, let's say school function, maybe annual function, maybe a function of wedding or something like that. Those, so you have heard these words in your real life. We would want to understand what they mean in the domain of mathematics, right? But before we actually start what relation and function in mathematics is, we need to understand another term, which is cross product of sets. Just let me rewrite this again. Cross product of sets. Now you'll be thinking what this cross product is, right? You have seen in the chapter of sets what cardinality of set is, right? Let's say if I have a set A here, which is having elements as 1, 2, 3, and 4, right? This is what we are having. And let's say if we are making another copy of this, or let's say we're having another set, let's change the name, let's change the elements for our own ease. Right. Let's say we are having small a, small b, and small c here in this set B. We have set A, we have set B. When we'll be saying cross product of sets, we will be writing that as A cross B. And how we'll be writing this A cross B? We will be mapping each element of set A with each element of set B. So what exactly we'll be having here? We'll be having one map with A, one map with B, one map with C, right? Similarly, we'll be having two map with A, we'll be having two map with B, and two map with C. We have mapped two with all the elements, right? Similarly, we'll be mapping now three with all the elements. So we'll be mapping three with A, we'll be mapping three with B, and we'll be mapping three with C, right? Similarly, we'll be mapping four with ABC. So we'll be having 4A, 4B, and 4C. So this is how all the mappings of set A can be done with all the elements of set B, right? So if I show you what exactly I've done here, let's say I'm taking the example of 2, we map 2 to A, we map 2 to B, we map 2 to C. Likewise, we map 3 to all the elements also, 4 to all the elements also, 1 to all the elements also. So this is the cross product A cross B, right? Can we have B cross A defined also? B cross A. Yes, B cross A is also defined wherever what exactly we'll be having. This is going to be ordered pair. Now I'm writing this form here. This form in sets you have understood. This, what form is this? This is the form of list or an array. So we were having two forms, roster form and tabular form. Which form is this? This is going to be tabular form. Tabular form or roster form. Right. This form, the second form that I'm writing in brief is the set builder form. Set builder form. So we are looking to find ordered pair x comma y such that x belongs to set B, means x is coming from the set B, comma y is coming from set A, right? Y is coming from set A. So these ordered pairs we are looking for. This is giving us the cross product. So if we write it in, so this is your set builder form. This is your set builder form. So I hope you do understand both the forms, how we can write cross product in tabular form or roster form, or how we can write it in set builder form. If I try to write this in the roster form, we'll be getting A comma 1, A comma 2, A comma 3, A comma 4, and so on. Similarly, B comma 1, dot dot dot, so on. Similarly, we'll be having C comma 1. So I'm not writing all the elements because you do know how we'll be writing these in the roster form. So this is the set builder form. And if we try and write set builder form for this, what exactly we'll be having? This is going to be a set of all those ordered pair x comma y, where this x this time is coming from set A, this y is coming from set B. This is exactly how we define cross product of two sets. Right? So I hope that is clear to you till now. If you have any doubt, you can let me know. And this x comma y we are writing, this is the ordered pair. This is the ordered pair. Right? Similarly, we can have ordered triplet also. What exactly that ordered triplet is going to be? So if we talk about ordered triplet, right? Ordered triplet. So what exactly that ordered triplet is going to be? If let's say we are having three sets which we are cross multiplying. Let's say if we are having A cross B cross C. So you can definitely will be doing the cross product of any two sets at a time. So you can find A cross B first and then take its cross with C, or you can take the cross of A with B cross C. Both are going to give us the same result. Both are going to give us the same result. And these can be written as the triplet x comma y comma z, such that x belongs to set A, y belongs to set B, and z belongs to set C. This is exactly how you can write the ordered triplet, right? Ordered pair, when we say it's going to contain two elements, x comma y. So, and when we'll be having ordered triplet, it will be containing three elements, x comma y comma z. So if I tell you that x, y, and z belongs to x, y, and z belongs to real numbers, x, y, and z belongs to real number, can I say this will represent the coordinates of all the points in 3D plane, right? So this will be representing, this will be representing coordinates of coordinates of coordinates of all the points coordinates of all the points in the 3D plane. So this is what these x comma y comma z will be representing. Similarly, if let's say we were having a cross b, and this was some x comma y, where x was belonging to set A, y was belonging to set B, and x and y both were coming from the set of real numbers, then this will represent coordinates of coordinates of all the points in a plane, all the points in a plane, and that too specifically xy plane this time, in xy plane. So in this case we'll be having xy plane. We might also be having yz plane or zx plane, whatever, depending upon what values we are taking, right? So this is how we can write ordered pair, ordered triplet. What does ordered pair mean when xy are real? What does ordered triplet mean? All those things are done. Now next part that we'll be having here is equality of ordered pairs. Equality of ordered pairs. So when can we say the two ordered pairs are equal? So if we'll be having x1 comma y1, and this is given equal to x2 comma y2. So if we'll be having x1 comma y1 and this is given equal to x2 comma y2, this will simply mean that the part, first element means x1 should be equal to x2 and y1 should be equal to y2. If these two conditions are met, then we can say that these are equal ordered pairs. These are equal ordered pairs, right? So if x1 is going to be equal to x2 and y1 is going to be equal to y2, right? Please make a note of this very quickly. Meanwhile, I'll be finding a question for you, right? And we'll be solving that question. I'm taking a question from your book, which you guys should be knowing, right? So yes, your question is coming on the screen. I'll zoom it out for you guys. So this is the question given to you. This is a question of your exercise from NCERT, right? So this question, it is given that if the first ordered pair x by 3 plus 1 comma y minus 2 by 3, and this is given equal to 5 by 3 comma 1 by 3. So what exactly this mean? The first part is going to be equal to the first one, and the second part is going to be equal to the second one. So if we try and equate this, I told you the first element of first order pair will be equal to the first element of second order pair. So we'll be having x by 3 plus 1 equal to 5 by 3. This will be giving us x by 3 equal to 5 by 3 minus 1, which is just going to be equal to 2 by 3. If we multiply both sides by 3, we'll be getting x as 2. So the value of x that we are getting right now is 2. Right. Similarly, we'll be equating the second order pair, and we'll be having y minus 2 by 3 equals to 1 over 3. Y minus 2 by 3 equals to 1 by 3. So this will be giving us y as 2 by 3. When this minus 2 by 3 goes to the other side, this will become plus 2 by 3, and 1 by 3 was already there. So this will be giving us 3 by 3, which is just 1, which is just 1. So we're getting the value of x as 2, y as 1. So x is 2, y is 1. So this kind of question you might find for 1 mark, where you'll have to equate the first part and the second part and find the value of x and y, or a and b, or whatever the variables that are given to you. Right? So I hope things are clear till here. We now understand what cross product is. We now understand what ordered pair is, and when can we say the two ordered pairs are going to be equal or not, and what an ordered triplet is. Right? I'll just try to find one more question based on this cross product, and let's see how we'll be solving this question. So the question is coming on your screen in less than a minute. Right? I hope you guys are ready for this. Let's look at this question. I'll zoom it out for you guys. Yeah, the question tells us, let A and B be two sets. Okay, there are two sets given to us. The name of the first set is A, the name of second set is B. Be two sets such that n of A is 3. What is n of A? 3. N of A is 3 means number of elements in set A is 3. N of B is 2. N of B is 2. So number of elements in set B is 2. Right? If x comma 1, y comma 2, z comma 1 are in A cross B, what exactly they are trying to say? X comma 1 belongs to A cross B. Y comma 2 belongs to A cross B. And Z comma 1 belongs to A cross B. If this is the meaning, that means X belongs to A, 1 belongs to B. This will simply mean that Y belongs to A and 2 belongs to B. And this will simply mean that Z belongs to A and 1 belongs to the set B, because we are given that X comma 1, Y comma 2 and Z comma 1 belong to the cross product A cross B. Right. And it was also given to us that A has 3 elements. We can see X is belonging to A. We can see from here X belongs to A, Y belongs to A, and Z belongs to A. So these 3 elements belong to A. So, and we were given that set A was having 3 elements only, and X, Y, Z are given to you as distinct also. So set A that we were having, is going to be x comma y comma z. This is your set A. Also, set B was containing 2 elements. So we have 1 belonging to the set B and 2 belonging to the set B. Only 2 elements were needed, and those 2 elements are 1 and 2 only. So this will be your set B. Right? Very interesting thing to see over here. If I ask you number of elements in A cross B, let's say, if very important point, this is a very important discussion. Let's say there is a set A which has P elements and set B which has Q elements, right? So number of elements in A cross B. So every element of set A will be mapped to the Q elements of set B. Right? If you see the first case, that you discussed over here, 1 was mapped to all the 3, 2 was mapped to all the 3, 3 was mapped to all the 3, 4 was mapped to all the 3. So instead of this, let's say if I was having P elements here, so every element will be mapped to all the Q elements here. So Q plus Q plus Q plus Q, P times. That's why we'll be having this as P into Q. So number of elements of set A is given to you, number of elements of set B is given to you. You'll be having this as Q plus Q plus Q dot 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 dot. How many times? P times. So we'll be having this product, this summation P times. So this is going to be P into Q. These many elements will be there in A cross B. Right. And if I ask you how many elements will be there in B cross A, how many elements will be there in B cross A? So every element of set B will be having P choices. So P plus P plus PQ times. I hope you do understand this. P plus P plus P dot 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 dot. How many times? This is going to be there Q times. So this will also be Q. So we are reaching at a very, very important result from here. This is super important result that you'll be utilizing in multiple questions. The number of elements in A cross B, number of elements in A cross B will be equal to number of elements in B cross A. So if you will be given either of these, number of elements of B cross A is given, you can find out number of elements in A cross B and the vice versa. Right. But important thing to note here, generally, if I ask you, normally in normal cases or maximum cases, normally A cross B is not equal to B cross A. I'm saying the number of elements in A cross B will be equal to number of elements in B cross A, but I'm not saying that A cross B will be equal to B cross A. So generally these two sets are not equal. These two sets are not equal. Right? Okay. So I hope we are sorted till here. We have understood what exactly do we mean by the cross product, and we have seen a result based on that also. Now the time is to understand what a relation is, right? As I told you, we have heard this term in our day-to-day life also, like relation of in a family, right? In relatives, and let's say if I ask you your siblings, your parents, right? Or uncles and aunts and all those are the relations that we have in day-to-day life. And what exactly and how exactly we are trying to define relation in maths, that is something that we'll be looking at. Okay, so I'll be taking the example of a set only, like the same way we defined cross product, same thing I'll be defining the relation also. Right, let's say I'm having initials of names here. Let's say I'm having A, B, and C here. And let's say if I expand it little bit, I expand it little bit so that I'll be able to write bigger things in this. Right, let's say I'm writing Amar, right, Ajay, right, Bhanu, Chiki, and Divya. Okay, let's say these are some of the names given to us in the second set. Let's say I'm calling this as set X. I'm calling this as set Y. Right now, A and B are already used. We are very much used to using capital A and capital B as the name of the sets, but they are used as the elements in the first set. That's why I'm putting the name of the first set as X and the name of the second set as Y. Right. So when we'll be finding the cross product, definitely cross product. If I ask you, so X cross Y. Please don't get confused with this. This is X cross Y. This is going to be A comma Amar, right? The next element is going to be A comma Ajay. The next element is going to be A comma Bhanu. So on, dot, dot, dot. Not just this, we'll be having A comma Chiki, A comma Divya. And similarly with B also, we'll be having B comma Amar, B comma Ajay, and like this. So this is the cross product that we'll be having over here, right? So we'll be having cross product defined in this manner. But part of this cross product, not the whole thing. Let's say I'm defining, we have to map the elements from set X to set Y in such a way that their initials match. That means A will be mapped to Amar, A will be mapped to Ajay, right? B will be mapped to Bhanu, C will be mapped to Chiki, and Divya will not be mapped to any of these. Right. So what exactly do I mean by this? So a subset of X cross Y is what I'm trying to say. So and that is what is going to be relation. So for time being, I'm defining it by R, which is going to be a subset of X cross Y, X cross Y, R, which is going to be a subset of X cross Y. We're defining this as A comma Amar, right? A comma Ajay, right? B comma Bhanu, and C comma Chiki. So these are some of the names that we have mapped with their initials from set X. Right? You can see this is not the whole cross product. But yes, definitely this is part of the cross product. Not just that, let's say if someone asks you, okay, we have to map it in such a way that the initial should not match. So yeah, A you will be mapping with Bhanu. Yes, A you will be mapping with Chiki, like this. And so on. B you will be mapping with Divya, let's say. So there are multiple possibilities of forming a such subset of this cross product. So every subset of this is going to be a relation on its own. It's going to be a relation on its own, right? So if I ask you what a relation is, if we go into the definition part, relation, if A and B are, excuse me for this, A and B are two non-void sets. Both of should not be void, right? So we'll not be having these as non-void sets. We'll not be having both of these as void sets. So if A and B are two non-void sets, then a subset of A cross B will be a relation from set A to set B. Any subset, or if you want, I can write it here, then A subset, in place of that, I'm writing any subset of A cross B will be a relation from set A to set B. Whatever subset you're trying to take, that is going to be a relation. So relation is denoted by capital R. Relation is denoted by capital R, right? So we denote the relation by capital R. And one thing is pretty obvious here, that R is going to be a subset, can be a proper subset, can be an improper subset. Yes, now you have to revise what we studied in the sets also, right? R can be a proper or improper subset of A cross B. So this is very important for us to understand, like how exactly do we define the relation from set A to set B, right? So, and another way of writing is the relation R is from set A to set B. The first set whose elements are mapped, right? So this we call as domain, domain of the relation. This we call as domain of relation. This we call as domain of relation. And the second set that we have is codomain of the relation. Codomain of the relation. Right? Codomain of the relation. Okay. The first set is a domain and second set is codomain. Right. Next we'll be having is range. We need to define what range is. Range. Range is going to be the set of all elements in the set of all elements as second elements. If I like rewrite this statement, set of all the second elements, set of all the second elements in the ordered pair, in the ordered pair. So set of all the second elements. You can see in the above example, if we look at this one, Divya was not mapped to any of these. Amar, Ajay, and Bhanu and Chiki were mapped. So only Amar, Ajay, Bhanu, and Chiki will be a part of range, whereas Divya will be a part of codomain, but Divya will not be part of the range. So I hope that is clear to you guys, right? So set of all the second elements in the ordered pair is known as range, is known as range, right? So this is what range for you guys is. If I talk about the relation R that we have defined, range of that R is going to be, we were having here Amar, we were having Ajay, we were having Chiki, and we were having Bhanu. Yes, and you do know the order doesn't matter. That's why I'm writing it in any random order. Yes, Bhanu was before Chiki, but I'm writing it in this way. Right, Amar, Ajay, Chiki, and Bhanu. So this is going to be the range of our relation. So domain is clear. Domain, if I try to explain it to you in simpler terms, domain is going to be set of set of first elements, set of first elements in the ordered pair, set of first element in the ordered pair. This is going to be your domain. This is going to be your domain. So if you take the example, above example, so if I tell you the domain of R is going to be, domain of R is going to be capital A, capital B, capital C. There might have been a possibility that there is some element which is not mapped at all, right? So definitely I'm not saying this whole is going to be domain, right? Domain of the relation is going to be only what is going to be the domain? Domain is going to be the first element of ordered pairs, first element of ordered pairs, right? So I hope that is crystal clear to you guys. We do understand what domain is, what range is. Yes, I'll be giving you a few questions to practice based on this, right? Now, let's just do a very simple deduction from here. Let's say if we are having number of elements in set A as P and number of elements in set B as Q, right? So now the question is how many how many relations how many relations are possible from set A to set B? How many relations are possible? This is the question that we are having. See, I told you that a relation is a subset of the cross product. So firstly, we need to figure out how many elements are there in the A cross B, right? So the number of elements in A cross B, which we discussed in the last class, the number of elements in A cross B is going to be the number of elements in A multiplied by the number of elements in B, right? Which we were having as P into Q. So we'll be having PQ elements in a set, PQ elements in this set, in A cross B set. If you remember what we discussed in the sets, I hope you do, right? Because we discussed that in detail. The number of subsets, the number of subsets is going to be 2 raised to the power number of elements, 2 raised to the power n, where n is the number of elements, and here the number of elements we have is PQ. So 2 raised to the power PQ, where PQ is the number of elements in A cross B. So these are going to be the total number of subsets, right? Now comes the discussion where we'll be discussing number of non-void sets or relations. Let's say if I'm saying definitely number of non-void subsets we are looking at, but that here becomes the number of non-void relations. So the discussion comes to this point that when are we going to get this void relation? Void relation will be when nothing from set X is mapped to anything from set Y. There is no mapping between, we haven't chosen any element from set X, we haven't chosen any element from set Y. So nothing from X maps to anything of set Y. That will be the case when we'll be getting non-void relation. So the total number of non-void relations are going to be total minus void relation, total minus void relation. And how many void relation will be there? Only one. So this is going to be 2 raised to the power PQ minus 1. I hope this is clear to you guys. Next discussion that we'll be having for is the number of proper relations. Number of proper relations. If you remember, number of proper subsets, exactly same thing. So we don't want the whole cross product shouldn't be equal to a relation. If I tell you a relation which is not equal to the cross product, it should not be equal to the cross product. What do I mean by that? Everything from set A shouldn't be mapped to everything of set B, right? In other words, if we have to write this thing, we'll be writing this as everything from set A shouldn't be mapped to everything of set B. Everything from set A should be mapped to everything of set B, right? And that is only one such case, which is same as your cross product, right? So if I have to ask you number of proper relations, if I ask you, that is going to be total minus improper relation, or total minus improper relation, which is going to be the same as that of cross product. So 2 raised to the power PQ minus 1 will be the answer that we'll be getting for this case. Yes, we are writing down a lot of things. We are deducing a lot of things. Soon we'll be using all of this information in the questions, right? So just stay tuned with me. So this void relation, if I ask you, or this improper relation, if I ask you, improper relation. Collectively, these two relation we call as trivial relation. Trivial relations. This is a name that we have given to both of these combined. If someone gives you that it's a void relation, yes, it's going to be a trivial relation. If someone tells you that this is same as the cross product, or this is an improper relation, then still it's going to be trivial relation. So sometimes you might be asked, number of non-trivial relations. Number of non-trivial relations. So this is what we are looking at. How many number of non-trivial relations will be there? So total minus void minus improper, right? So this is going to be 2 raised to the power PQ minus 1, or 2 raised to the power PQ minus 2. These many non-trivial relations will be there, right? So I hope we do understand that relation is just a subset of the cross product. So we have basic idea about what uh, relation is. Then we understood that it's just a subset of cross product. After that, we studied about its domain, right? Range, codomain, and after that, we saw the total number of relations, then non-void and non-trivial or proper relations. All those things we've seen, right? It's time to move on to a question right now. Okay, so I'm picking a question for you, right? So a question is on your way in less than a minute. I hope you guys are prepared. Are you? So there's a question on your screen. I'm zooming it out for you guys. Let's read this question together. The question is saying us, let A is a set which is 1, 2, 3 up to 14. Yes, A is a set given to us where the elements are natural numbers from 1 to 14. Define a relation R from A to A. Yes, we can define this also. So I hope you are not getting confused that both the relations will have to be different. That's not the case always, right? So what exactly we can have here? We might be having the same set here. This is set A. This is set A. We are having elements 1, 2, 3 up to 14. Here also we are having 1, 2, 3 up to 14. So these are two set or the same set A. There are two different ways of saying the same thing, right? There are two equal sets A and B, or the same set A is written twice, and we are defining a relation R from A to A. If I write this in the relation form, relation R is defined from A to A. Okay, now let's read the question once again. A is 1, 2, 3, 4 up to 14. This set A is 1, 2, 3, up to 14. We have natural numbers till 14. And the relation is given to us in such a way that relation R is a set of all those ordered pairs x comma y where 3x minus y is 0. 3x minus y is 0. And obviously your x and y are coming from set A. X and y are coming from set A. We are supposed to find its domain, we are supposed to find its codomain, and we are supposed to find its range also. Okay, so this rule will be helping us solve the question. We are given 3x minus y equal to 0. What exactly does that mean? If 3x minus y is 0, This means y is going to be 3 times of x. So x, right? I hope you do understand that x is coming from this set, domain part. X is coming from set A, and y is also should be a part of A. X should be belonging to A, y should be belonging to A, because y is the set of output. So this x will be coming from the first set and y will be coming from the second set. Right. So we'll be taking different values of x, and let's say what's the value of y we're getting. X we are taking as 1, 3 times 1 is 3. X will be taking as 2, 3 times 2 is 6. X will be taking as 3. Next we'll be getting as 9. X will be taking as 4. We'll be getting y as 12. X if we take as 5. 5 3 is a 15. Is 15 a part of your codomain? No, 15 is not a part of your codomain. So this will not be taking. Similarly, 6 comma 18 will not be taking. So what all elements are going to be there? You will be having 1 comma 3. This will be belonging to the relation R. 2 comma 6 will be belonging to the relation R. I'm just showing you how we can write whether an ordered pair belongs to a relation or not. So dot 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 something in this way. And similarly, we can say 5 comma 15 doesn't belong to the relation R. 5 comma 15 doesn't belong to the relation R. Similarly, 6 comma 18 doesn't belong to the relation R. This is also a way of writing. And if I have to write, see, what form was this? What form was this? This form. I hope by now you're master of this, that this was your set builder form. Just let me go back to where we were. Right, I'll just bring it to the left side. This is set builder form. If we have to write this in the roster form, how exactly we can do that? Relation R will be, now will be actually writing the ordered pairs. Right, instead of writing a rule, it's going to be 1 comma 3, it's going to be 2 comma 6, it's going to be 3 comma 9, it's going to be 4 comma 12. 5 comma 15 will not be a part of this because 15 is not a part of set A. So this is your relation R. Okay, I'm collecting things in a very specific manner now. I'm collecting all the ordered pairs, all the first elements of the ordered pair. 1 comma 2 comma 3 comma 4. What is this going to be? The set of all the first elements. This is domain of the relation. Domain of the relation. Right. If I collect all the second elements, this is 3 comma 6 comma 9 comma 12. This is going to be your range of the relation. This is going to be your range of the relation. Right? So we have domain with us, we have range with us, codomain. Okay, codomain is going to be the whole set itself. If someone asks us what's going to be the codomain, 1, 2, 3, up to 14. This is going to be your codomain. The whole set itself is going to be your codomain. So domain we found out, range we found out, codomain we found out, and we written this in the form of roster form also. So that is also something we have done. Look at this once, and then I'll be bringing another question for you. I'll be bringing another question for you, which will be helping you strengthen your concepts. Right? It will be clarifying your doubts, whatever doubts you'll be having till now. Okay, so this is I hope the given query or the given question that we discussed right now is clear to you. We'll be discussing one last question and then we'll be done with the concept of relation. Right? This is an arrow diagram given to us. Definitely set P has three elements 9, 4 and 25. Set Q has 5, 3, 2, 1, -2, -3, 5. So these are the elements given in set Q. So the question asks us, firstly, is everything of set P mapped to everything of set Q? No. Right? Because 9 is mapped to only 3 and -3. 4 is mapped to only 2 and -2. So this is definitely not the cross product, but yes, part of the cross product. So definitely this is going to be a relation R. Relation R is defined from set P to set Q. What exactly we have to do in this case is we have to write this R in both the forms. What form? We know what forms we have. We'll be writing this in the set builder form. We'll be writing this in the set builder form, and then we'll be writing the same thing in roster form also. Roster form also, right? And then after that, we'll be finding its domain, we'll be finding its range also, right? So that is also something we'll be doing. So let's move on to solving this question. The easier part is writing it in roster form. When the number of elements are less, writing roster form is pretty easy, and definitely that will be helping you. It will be helping you write the set builder form also. So you can see 9 is mapped to 3, 9 is mapped to -3, 4 is mapped to 2, 4 is mapped to -2, 25 is mapped to 5, and 25 is mapped to -5. So this is the mapping that is given to us. This is the relation that is given to us, right? So definitely the easier part is we can write the domain and range. Yes, but let's observe the pattern that is given here. What I can see is this 9 is the square of 3. This 9 is the square of -3. Similarly, 4 is the square of 2 and 4 is the square of -2. So can I write this relation R as ordered pair x comma y, ordered pair x comma y, such that this x is the square of y. X is the square. You can see 3 square is 9, -3 square is 9. Similarly, 5 square is 25, -5 square is 25. So first element is the square of second element, where this x and y, x belongs to P and y belongs to Q. So x belongs to P and y belongs to Q. So this is the relation that we have written in the set builder form. So till now, I think we are pretty much clear about how to write a relation in the set builder form or in the roster form. Right. So this is clear. Now we'll be writing the domain. What was domain? What was domain? Collection of second elements. No. Collection of the first elements, right? So collection of first element, if we're trying to take, we are having 9, we are having 4, and we are having 25. These are the elements that are there as the first element of the ordered pair, right? And now if someone asks us what range is going to be the collection of all the second elements. That means we'll be having -3, 3, -2, 2, -5, and 5. So these are going to be your range, part of your range. So this 5 will be a part, 3 will be a part, 2 will be a part, 1 will not be there, -2, -3, and -5. These are going to be the part of your range, and the whole set Q itself, will be the codomain. If someone asks you what is the codomain, you can say the whole set Q is your codomain. Right. After this, I'll just tell you one simple thing, that is inverse of a relation. Inverse of a relation. So let's say if initially a relation R is defined from set A to set B, right? Then its inverse denoted by R raised to the power -1. This is not the reciprocal of relation, guys. Please do understand. This is not the reciprocal. This is inverse of a relation. This will be defined from set B to set A. So now you're having relation from set P to set Q. Instead, if you're having relation from set Q to set P, that is going to be inverse of this relation. So one good observation from here is domain of R, domain of the first relation will become, this will be becoming the range of R inverse, and range of R is going to be the domain of R inverse. So this is also something that you can figure it out from here. If let's say ever you find the questions of inverse of a relation, you don't have to get confused. It's just simply the two sets will change its position. Initially, if the relation is from A to B, the inverse will be from B to A. And the domain and codomain will also be swapped, right? So I hope everything is clear to you from here. That's it for today. And in the next discussion, we'll be having functions with us and we'll be discussing functions. Till then, take care. Bye bye.